So in this unit, we're going to do some quick percent review, and then we're also going to practice finding percent problems. So first, let's talk about changing a percent to a decimal. So for example, down here, I have 73.5%, and I want to change that to a decimal. The way that I do that is I'm going to move my decimal point 2 places to the left. And so this would end up being 0.735. So move the decimal twice left, which is really like dividing by 100, but most people just think about it as moving the decimal. To change a decimal to a percent, we're going to do the exact opposite, which means we're going to move the decimal twice right. And so for example 2, when I see 0.175, if I go twice to the right, that means I'm going to get 17.5%. Now on example 3, I already have a percent, so I want to make sure I'm still moving it twice to the left to make it a decimal, and so that's going to become 0.001. One hint that I use is if I forget which way to move the decimal, I think on the alphabet, if I needed to go from the letter P to the letter D, percent to decimal, I would go to the left. And if I needed to go from the letter D to the letter P, decimal to percent, I would go to the right. To change a percent to a fraction, so for example 2/5, you have some options. Option 1 is you could change this to a decimal first by typing that into a calculator, and then you could follow the steps up here to change a decimal to a percent. Or you could make it directly into a fraction by making it an equivalent fraction with a denominator of 100, because that's what percent really means. It means out of 100. So we'd want to know 2 out of 5 would be how many out of 100. So to change a fraction to a percent, you can make an equivalent fraction with a denominator of 100. And so in this case, I now have a proportion. I could either solve it like a proportion using cross products, or occasionally with proportions, there's also shortcuts. So in this case, I can see that to get from 5 to 100, I would multiply by 20, and to do that, I have to do that to the top as well, which means that 2/5 would come out to 40%. So 2 out of 5 would be the equivalent of 40 out of 100. To do this with 3/8, that means that I would set up 3 over 8 equals something over 100. Now in this example, I can't think of a number that I could multiply 8 by to make 100, so I'm going to solve this like a proportion using my cross products. So one of my cross products, 3 times 100 is 300, and my other one is 8x, and then to get x by itself, I would divide both sides by 8, getting me 37.5%. And you can definitely use a calculator. The last thing I'm going to do is change a percent to a fraction, and so to do that, I know that 73%, for example, means 73 out of 100, so I can literally just put the percent over 100 and simplify if possible. So on example 5, 73% means 73 out of 100. That cannot be simplified. And 140% means 140 out of 100. And then I could simplify that. First, I could cut off my zeros, getting 14 over 10. And then if I divide top and bottom by 2, I would get 7/5. So 140% as a simplified fraction would be 7/5. This would be kind of like, say, a test had 5 points on it and you earned 7. You're actually earning more points than are available, which is why the percent is over 100. So here we're going to use the percent proportion to solve percent problems. One of the ways we can do that is using this proportion called is over of equals percent over 100. It's possible you've seen it before as part over whole equals percent over 100. Let's see it in action here. So it says, what percent of 25 is 17? So the first thing I'm going to do is I'm going to set up my proportion template, like this. And in my percent proportion, it's is over of equals percent over 100. So the thing that never changes is that there's a 100 right here. So then I look to see what words help me identify where these numbers are going to go. I clearly have 2 numbers, but I have 3 spots. So I see that this word of is attached to the number 25, and the word of is attached in the bottom here. So I'm kind of identifying that, of 25. So I'm going to put the 25 in the bottom. Then up here I see that I have the word is, and I also know that the word is attached to the number 17. So I'm going to put the number 17 on the top here. That leaves me with one empty spot above 100, and so that's an unknown, and that's going to be my x. It makes sense that it's my x or my variable because I don't know the percent. So I could solve this like a proportion using cross products, or I could see if there's any shortcuts available. And so one shortcut that I see is that if I do 25 times 4, I would get 100. Whatever I do at the bottom, I do at the top. 17 times 4, I could do that on a calculator. If I didn't know that, I could do 17 times 4 and get 68. And so that means that 17 is 68% of 25. That also makes sense to me because 68%, I use kind of 50% as a benchmark. 50% is about halfway, and 68% would be more than halfway, and 17 is more than halfway to 25. So that's a good benchmark to use. Let's look at the next one. So the next one is asking me what number is 30% of 90. So I'm going to start by setting up my proportion template, and I'm going to put in my 100. The first thing I see is that I've got this 30%. So since that's the percent, that's going to go over the 100. That means 30 out of 100. Then I still have my 90. That has the word of attached to it, so I'm going to put that on the bottom over here, which leaves one spot left for my unknown, and I'm going to make that into my x. And so then it makes sense that that would be my unknown because it's asking what is. So I'm going to use my cross product since this time I can't see a shortcut to get from 90 to 100. So instead I'm going to cross multiply, and I'm going to get 2700. 9 times 3 is 27. I'm going to add 2 zeros, and then 100 times x is 100x. Then I'm going to divide both sides by 100 to get x by itself. And if I do that, I get x equals 27. And so my number, the number that's 30% of 90 is 27. This makes sense because 30% is about 1/3, and 1/3 of 90 is 30. And this last one here, I'm going to set up the same thing. I'm going to set up my proportion template. I'm going to put in my 100. I notice that first I have my percent, 12.5, and so that's going to go above the 100 because the percent always goes above the 100. And then also I have an is, 20 is, and so that's going to go here where the is goes. My of is my unknown, and I cannot find like a quick multiplier from 20 to 12.5, so I'm going to cross multiply. So 20 times 100 is 2,000, and 12.5 times x is 12.5x. Then to get x by itself, I'm going to divide both sides by 12.5. And if I do that in my calculator, what I end up with is 160. Which again makes sense because 12.5% of a number is not a lot, and 20 is not a lot of 160. So what you're going to do now is you're going to pause the video, and you're going to try examples 9, 11, 12, 13, 14, and 15. Press play when you're ready to check your answers. So on each of these examples, how we would set it up, for number 9, you would do is over of 51 over 136. You would cross multiply to get 5100 equals 136x. Divide both sides by 136, and you get that it's 37.5%. On example 11, you've got is 49 of 56, so is over of equals x over 100. Cross multiply to get 4900 equals 56x. Divide both sides by 56 to get 87.5%. Over here, we've got 11 over 55 equals x over 100. You could cross multiply to get 1100 equals 55x. Divide both sides by 55, and you're going to get 20%. On number 13, you can cross multiply to get 100x equals 4,140. Divide by 100. That would move the decimal back 2 places, and your final answer is going to be 41.4. On example 14, since it's asking for 140% of 50, I know that my answer should be bigger than 50, because it should be more than 100%. So that's important to know. So when I cross multiply, I'm going to get 100x, and when I cross multiply this way, I would get 100x equals 7,000. And so when I divide both sides by 100, I get 70. And the last one, I've got what number is, so I don't know my is, over 85 equals 12% over 12%, which is 12 out of 100. Cross multiply, and then to isolate x, I divide by 100, and I get 10.2. So on these problems, we are finding the percent of students that chose a certain type of pasta dish. So this is where it might make more sense, and rather than thinking of it as is over of, it might make more sense to think of it as part over whole equals percent over 100. So for mac and cheese, I can see that 33 students chose mac and cheese. So that's the part of my students that chose mac and cheese, 33. And all of my students, my whole, is 220. And they told me that up here. I also could find that number by adding up all these students together. That would also give me 220. And then I'm asking for the percent, so that's my unknown, equals 100. So I'm going to cross multiply, and I'll get 3,300 equals 220x. Then I'm going to divide both sides by 220. The first thing I notice when I'm dividing by 220 is they both have a 0, so I can cut that off. So it's really like dividing 330 by 22. But you could divide in your calculator the 3,300 by 220, and you're going to get x equals 15%. Pause the video to try lasagna to find the percent of students that chose lasagna. Press play when you're ready to check your answers. So in this case, 40 students chose lasagna out of 220. Cross multiply, divide by 220, and you get that it's 18.18%. You might have rounded to 18.2, which is fine. The next word problem says students were asked how much they would tip for a $28 meal, and this shows the number of students and how much they would tip. So the first one is asking how many students said they would tip $4.20. So 36 students would tip $4.20. So that's the part. Now the whole is how many students tipped in the first place. And so in order to find that, I need to add up all of these numbers. So I've got 19 plus 28 plus 45 plus 36 plus 47 plus 8, and that comes out to 183 students. And I'm trying to find the percent. So for right now, what's important to know is that in the original problem, you were told this number, $28, and it actually doesn't really matter right now. It's just saying that the meal was $28, but we're talking about percent of students, not percent of money right now. And so to solve this, I would cross multiply and get 3,600 equals 183x, and then divide both sides by 183. And the percent of students that would tip this would be 19.7%. So pause the video to find the percent of students that would tip at least $5 and then $5.60. Press play when you're ready to check your answers. So for at least $5, we need to make sure we include the $5 and the $5.60. And so that was a total of 55 people that tipped at least $5. Out of 183, using our cross products, we end up with 30.1%. $5.60 was 8 people out of 183. Using our cross products, we end up with 4.4%. Now this last question is going to refer back to the price of the meal. So the price of the meal was $28, and it's asking what was the adequate tip to leave. So most people would say a good tip to leave is either going to be 15 or even 20%. And so you could do what number is 20% of 28, and that would help us find this. We could cross multiply. Another way to find 20% is you can say that 20% is double 10%. And the quick way to find 10% is to move the decimal place back one. So 10% of 28 would be $2.80. And so if I want to find 20%, I can just double that, which would be $5.60. So only 8 people left a 20% tip, which is kind of interesting. To find 15%, some people might leave that as well. You could think of 15% as 10% and 5% combined, and 5% is half of 10%. So if 10% was $2.80, then 5% would be $1.40, and then if I add those two up, I would get $4.20. And so we can see a decent amount of people actually left 20% or 15% or more. And you do not need to do this slide for now. We'll talk about it next week.